Welcome to The Explainer. Today, we are going to demystify something you do, I don't know, 100 times a day, but probably never really think about. And that's the incredible journey your data takes across the internet.
I mean, it feels totally instantaneous, right? You hit enter and boom, there it is. But what's really going on is this incredible high-speed journey your request takes, all the way across the globe and back. So let's pull back the curtain and see how that simple click unleashes this complex, super coordinated dance of data.
Okay, so it all kicks off with that one simple action from you. That single click or tap, it sets two key players into motion. And you've got to know these two, the client and the server. They're like the fundamental duo that makes the entire internet conversation even possible.
First up, we've got the client. Now that's just a fancy word for your device, your laptop, your phone, whatever you're using. Just think of the client as the one asking the questions, the one saying, "Hey, I'd like to see this web page, please."
And then, on the other end of the line, you've got the server. This is a seriously powerful computer, right? Its whole job is to store all that website data and, well, serve it up. It's just sitting there constantly listening for requests from clients like yours, ready to send the right info back.
Okay, so here's where it gets really cool. How in the world does your device find the exact right server out of literally billions of computers all connected to the internet?
Well, it's not magic, though it kind of feels like it. It's actually a system, a really brilliant one, that works just like a giant, super fast address book for the whole internet.
See, you and I, we use memorable names, right? Like a website's domain name. But computers, they don't really care about names. To find each other, they need a super specific numerical address. It's a unique identifier, and we call it an IP address.
So, what's the thing that translates the easy-to-remember name you type into the numerical address the computer needs? That system is called DNS, which stands for Domain Name System. And honestly, the best way to think of it is as the internet's phone book. It's a perfect analogy. So it's basically this quick three-step dance. First, your computer asks a DNS server, "Hey, what's the IP address for this website?" Then the DNS server zips through its massive records to find the matching number. And finally, it sends that correct digital address right back to your browser. And just like that, you now know exactly where to send the real request.
All right, so we've got the address. Your computer is ready to send its request. But here's the thing. It doesn't just shout the entire message across the internet all at once. Nope, it's way smarter than that. It breaks it all down into these smaller, much more manageable pieces.
And why does it do that? Well, it's all about being efficient and reliable. Think about it. If one tiny piece gets lost or messed up along the way, you only have to resend that one little piece, not the whole giant file. It just makes the whole system way more robust.
And these small, digestible little chunks of your request, they have a name: network packets. Now, for all of this to work perfectly, billions of times a second, all the devices have to speak the same language. This agreed-upon language is called a protocol. It's just a set of rules for communication. And the big one here, the one you should know, is TCP/IP. It's pretty much the bedrock of the entire modern internet.
And what's inside each packet is, well, it's brilliant, and it's all laid out by that TCP/IP protocol. You can think of every single packet like a tiny digital envelope. It's got the from address, the sender's IP, and the to address, the receiver's IP. It also has a sequence number, which is super important for putting them all back in the right order later. And of course, it has a little piece of the actual information.
So now, let's talk about the journey itself. Let's follow these packets as they travel across this vast, incredibly complex, and yeah, sometimes even dangerous network we call the internet. So each one of your packets starts this crazy fast game of hopscotch. They're literally leaping between these specialized computers called routers. And these routers, they act like traffic cops for the internet, constantly calculating and guiding your packets along the fastest, most efficient paths to get where they're going. But before those packets get too far, they almost always have to pass through a really critical security checkpoint. And this is just one of many, many security layers that protect networks all over the world. And that checkpoint is called a firewall. The name is pretty descriptive, right? Just think of it as a digital gatekeeper or a virtual wall that stands between your safe, private network and the kind of wild, open internet out there.
So what does it do? Its job is to look at the details of every single packet trying to get in or out. And based on a set of security rules someone has programmed, it makes a split-second decision. Are you safe to come through, or nope, you're blocked? It's what protects your network from hackers, malicious data, all that nasty stuff.
Okay, so let's say your request packets made it. They successfully passed through all the security checks, and they finally arrived at the destination server.
Now, the server gets to work.
So first things first, the server gathers up all the little packets you sent. It looks at their sequence numbers and puts them back together, kind of like a puzzle, until it has your original, complete message. Then it goes and grabs the website stuff you asked for, the text, the images, the code, and it breaks that down into a brand new set of packets for the trip back home to you.
In this return trip, it's pretty much a mirror image of the journey out. These new packets, the ones carrying the website's data, they start hopping across all those routers, they pass through the firewalls, and they're all addressed specifically to your device's unique IP address.
And finally, your computer starts receiving this stream of packets. Your web browser gets to work, super quickly reassembling them in the right order, and voila! In way less time than it took me to explain all this, the complete web page just appears on your screen.
So yeah, the next time you're just browsing online, take a second and remember this incredible, super coordinated journey that's happening behind the scenes. It's not magic. It's a lightning-fast conversation happening between computers all over the globe. And it happens for every single click you make.